This is World Oil Deep Dive's special series on oil field electrification technologies, powering today's oil field for tomorrow's energy. Join us as we talk with industry experts about technology ranging from microgrids to E-Frac to offshore electrification and more. Now, here's today's episode.
All right, we're still here in Duncan, Oklahoma, and it has been a wonderful morning. We've been here at the Halliburton facility in Duncan. For those of you who don't know, Halliburton was actually born here in Duncan, Oklahoma. So this is a kind of a company town. There's not too many things you can do here. You can do agriculture or you can do Halliburton. And so, and you've seen all the tech we've been showing off today, but now we're getting really to, should I say the heart or the brains? What do you guys like to use?
The brains.
The brains. Yeah. The brains of the tech. So we have with us today Faraaz and Price. And hey guys, before we get rolling on this, why don't you tell the folks a little bit about your background and what exactly you work on here at Halliburton?
Yeah. So I'm Faraaz Adil. I'm the Senior Product Line Manager for Unconventionals within the Production Enhancement PSL. I've been with Halliburton almost 15 years now. I started off as a young frac engineer straight out of school, and Halliburton has given me the opportunity to work across different geographies. I've worked in India, in Abu Dhabi, traveled around different areas, and last 5 years I've been in the US. In my current role, I'm focused on building this product out where we are making a lot of effort in scaling subsurface monitoring. So that's what my entire area of focus today is.
Wow. How did you get to that? Because that's not exactly frac stuff, right? I mean, when you talk about subsurface monitoring, that's kind of a sidetrack off of that. Was that just an area of interest that you jumped into, or?
Yeah. So for us to understand what's happening in the subsurface, you need a very strong frac background. So my experience with frac helps. And Halliburton gave me the opportunity to go and learn the other components associated with being able to use technology to implement my knowledge of frac and then build this product out.
Okay. Yeah. All right. And Price.
Yes.
Same thing. Tell the folks a little bit about yourself and what you do here.
No problem. My name is Price Stark. I am the commercial champion for PE Frac Technology. So my job is to bring a lot of the technologies you've seen here today to the market and collaborate with our customers to find uses and value for them with them. My background, I've been with Halliburton about 12 years, and I actually came up as a project manager running high-end technologies, fiber optics, things like microseismics in the past. We had tilt meters all throughout the world, China, United States, UK, actually ran some there. And then I've been, the last few years, handling accounts with our frac services, helping them with wireline services, our completion tool services. So several different customers. And so the combination of understanding these technologies and then actually understanding sort of our business development process has brought me to where I am, where I'm handling that aspect here internally with the frac division.
Excellent. So here today we're going to talk about the brains, or is it fair to say brains? Because does it really control everything, or is it more subsurface data?
It's giving you the synapses and the neural response of what decisions you should be making. And it's giving you that feedback loop where it's providing you an insight of what's happening downhole for you to be able to go and make enlightened decisions of changing things, modifying things, so that you can maximize your asset value.
Yeah. So now that knowing what's going on downhole is a very difficult proposition, right? Everybody wants to know what's happening downhole. What is, the things we're doing up here, how is that affecting what's going on? So how did you guys crack that? I mean, what's involved? Is it fiber optic? Is it sensors attached to wellheads? I mean, how does that work?
So we have been doing fiber-based applications for the past few years now, but we always had a barrier of how do we scale this, because what we had in the past was it was not cost effective. It used to interfere with the frac operations, so efficiency wise it had a little bit of a challenge there. And with this product what we have brought to the table now is we have used new technology where we are using a disposable fiber in an offset well to effectively provide a very similar output to what we were getting before. And now we are also using a new technology which we are launching this year called Sensori Pulse, where you're able to generate a measurement in the well that you're actually fracking and get a quantitative number across it for every stage. So you are able to tie in what you're seeing between the wells. You're seeing the fracture growth between the wells with fiber.
Right.
And you're tying in with a very simple, non-intrusive measurement that's happening on the wellbore together. You're able to tie these measurements together to give a comprehensive view of what's happening with your fracs.
Wow.
Yeah.
That's impressive, because once you have that data, and it goes into this beautiful box over here too.
Yeah.
You know what I'm saying? This is the Sensori Cube.
Yeah.
And you can see that for the folks who are just listening audio. What is that, about 3.5, 4 feet by 3 feet?
It's about 5
About
feet by
box,
5
about
feet, yeah.
5. Yeah.
Yeah.
And so it's a box, but if we could look inside there, what's in there? Just a bunch of circuit boards and stuff.
Yeah, so it's a box that enables us to execute everything remotely, and it allows us to run a lot of automation where we have eliminated the need for having a human sit and like process data for weeks. Now we have got algorithms and automated protocols that effectively run everything in real time and process everything in real time. So you've cut it down from like 4 weeks of processing to a couple of seconds. And
4 weeks to a couple of seconds.
Yeah, 4 weeks.
And because this is, we're not talking about edge processing or any of that. We're talking about, in situ processing, right? You
Yeah,
put this
right.
box out on
Correct.
site,
Yeah.
and it's just doing everything
all,
right there.
all you're doing is you're just taking this cube out and you're dropping it on the well site. You're hooking up 2 cables, like one is for a generator, one is for a fiber optics, and then it's got hardware inside, which is allowing us to process this data. It's got a Starlink connection on top, which basically just routes all the information that's processed into a cloud and then into a data lake in the back. So we've got apps, phone apps built out. We have got a web platform built out. And we have gone from a time where the customer had to wait for a couple of days, weeks to get a report handed to
Right,
them.
exactly,
But
yeah.
now they can just pick up their phone. They wake up from their sleep. They're somewhere busy in their day. They pick up the phone and they can have a look at exactly what's happening in the subsurface. So that's where we are today.
That's amazing. And so armed with this data and the systems we've seen here today with the automation, I mean, that's really like closing the loop, because now you can give that information back to the automated systems, right, to help make decisions?
Yeah.
Yeah, I mean, this is little known, but several years ago we did a function test where we ran a closed loop frac. We actually had sensors and data transmitting to corporate towers. Machine learning was working on that. It was sending designs back to the field. That those designs were going into the ground. We didn't have any humans in that process, and it was a function test. It was
Right.
just, could this be done?
What year was this? How long ago?
This was 2021.
Oh, okay.
And so it could be done,
Right.
was the answer. But it wasn't ready yet. The systems were intrusive, like we talked about. The links weren't very well. The automation wasn't robust. I think you've seen now sort of the automation that we had to come up with to make this, to enable it. And so we need to simplify the whole process. And that's what we've done here is we've sort of simplified it all down so that any fleet in our inventory can go and generate these results, acquire this data, and now start bringing it all together, working towards the goal of ultimately closing that loop again.
Yeah. So give us an idea. A lot of the folks who are listening, they're engineers, the operating companies, they like case studies, right? They want case studies. So do you guys have some really good examples of, how that's helped in an actual situation?
Yep. You want to take the prize? Yep.
Yeah. Okay.
I can take it, if you want.
Yeah, go ahead.
Yeah,
Faraaz.
okay.
I was like,
So a couple of ways that we have seen operators use this information is where it's first of all enable them to keep acquiring subsurface data, dynamic subsurface data on every pad. Mm-hmm. So they are collecting that information from one pad to the other pad and just continuously doing it. And as they're doing it, it's giving them an understanding of what parameters they need to optimize. So they're looking at, hey, what are the specific data sets or data points that we can optimize? Like as an example, one thing that operators keep looking at is like volume to first response. Mm-hmm. What that means is if I'm fracking on well A and I have these sensors on well B, how much time is it taking for the fracs to grow from well A to well B?
Right.
And they're looking at the data to then optimize the spacing between the wells, the total number of wells they need to put on a DSU. And that is one form of optimization that's happening. Another application that we have seen, which we recently published on as well, is where the operator used the technology to basically use it as a well surveillance tool, where they were trying to optimize the distance between their rigs and where they are fracking,
Right.
so that they do not have interactions. and they basically use the technology to have it as a traffic light system or an alarm system, where if a frac was coming its way, we could raise the flag, and then they could either stop pumping operations or they could notify the drilling rig. So it's
interesting.
There are a variety of applications that the technology can be used for.
Oh, that's fascinating.
Yeah.
Did you have some there too, Bryce?
Well, I mean, the applications are growing fast. I mean, the other thing we're looking at, we talked about the pulse technology, and this just gives us sort of a metric of, okay, you just completed a stage. Was it open, right? And so right now, the customer might just go, hey, I did a stage, it was this long, it was maybe 8 clusters, and it's open. But now I can give you a benchmark. I can say real time, okay, that was good. 90 out of 100, you're good. Right. Just keep going, right? In fact, maybe push your limits a little. Go 9 now. Hey, it's still a 90. Keep going. You're fine. If you do get to the point where, we went to 14 and it falls to a score of 20 out of 100. Whoa, back up. Exactly, that was too fast. But this isn't forward modeling or looking at spreadsheets and trying to estimate. I mean, you're receiving empirical data live that's telling you, hey, how are your decisions impacting what you're trying to do?
Right.
And so that's what we're going for.
Yeah, but with the systems, then I guess the future of that is you tie this in, like you were saying, in that model, the early model, but now we have better automation systems, we have better data collection, so now we can have a continuous feedback loop to optimize, right?
The entire architecture is in place now with the Octave Auto Frac, which you got to go play with. I think you got to run it, right?
Yeah, I got to run it.
Yeah, you need a job as a frac. Yeah.
I know, right?
But now, it receives inputs. You can type it in like anyone would put into a spreadsheet today, but it can also receive those remote. So now with that architecture, the fact that all of this data is going to the cloud where we have our treatment data as well, have other sensors we can bring into that as well, it's not hard then to see, okay, all we have to do now is connect these two systems.
Right, yeah, exactly.
Right? And so where we're at today is we need the data. Right. Where we're sitting with customers who are going, hey, I understand this. I want to move to that. Let's enable this, Halliburton. We got to start collecting data. And that's step one. And so we're out there actively on fleets today, collecting all the information, the baseline data we need so that we can start enabling the system to make changes.
Yeah, because a lot of those other, the above surface technologies, those are there, but this is like the missing piece, right?
Yeah. Right.
Because now you need to get as much data as all of those surface level equipment have been throwing off, but now you can start collecting that. And so how long is it before you get out there, get everything set up and start using it before the data becomes usable, right? Before you get actionable data, basically.
So we are in that phase right now where we are collecting data, and we are seeing, as an example, the first project or the first pad that we went and deployed the technology on. After the end of that first pad, there were insights that we could draw immediately from that.
Really?
We could see things that were happening that we could observe, and we are cataloging it, saying that, hey, look at this. There is a very unique behavior, and we have to account for this when we are designing the jobs in the future. And you can start making minor tweaks, and it's going to be a continuous process. It's not going to be that we say that, okay, fine, we'll capture data for 10,000 stages and only then we'll make a change. You can start making changes early on, but we are building towards a model where you can have a whole decision-making workflow built out based on the data that you're looking at from each of these projects.
Oh, wow. Okay.
Yeah. And it goes back to what Bryce was saying earlier as well. He was giving an example of what you can do with the pulse data, where you are looking at that data, you know what the parameters are or the KPIs are of what you're looking at, and you define the boundary constraints associated with it. And then you can have the following decision made if you meet those criteria.
Right, exactly.
Yeah, and we are building that
situation.
Yeah, correct. And we are building that today. Yeah.
I mean, our goals will be, people are making manual changes today, no doubt, right? They see the data, they can make a manual adjustment either on that well, on the next well. But we're rapidly approaching where those changes will occur naturally in the system. I mean, I've seen timelines that companies have put out, or just talking to people at various conferences where they say maybe we could get to a closed loop frac in 10 years. And what we're trying to say to the world is it's going to be much sooner than that.
Right.
The automation, these capabilities, we're talking it's going to be a couple of years maybe, or a year, or maybe the end of this year.
Wow.
Right? I mean,
Wow. That's crazy, right?
We don't know, right? We have to collect that data, but this is happening.
No, I'm quoting you, Price.
Yeah.
Price said it was going to happen by the end of this year.
Yeah.
That's it.
But it's much faster than people, I think, are realizing.
Yeah, well, the speed of change, in our industry, when you look back, we started out talking with Sean kind of about the history of frac and stuff.
Yeah.
And he's like, the changes, the tranches of accelerated change just keep getting tighter and tighter,
Yeah.
And this is one of those examples. To have all the components in place where we could do this, as soon as somebody wants to bite it off, basically, and say, bring all this stuff, make this happen for me, it's all there in place for them. This is something that that's one of those, 10 years from now, that's one of those things that all people always think is in the future, but it's not. It's now. It's now, right?
That's my big takeaway. If anyone listening, and you take something away from this, it would be we've simplified this process. These boxes are with our fleets today. The fleets are carrying them from pad to pad with them, recording the data on every pad, every stage they can get this information. We're doing that now. It's happening, and it's only a matter of time before those decisions start being built out, and that it becomes, we connect these systems together, and it just starts running.
That's spectacular.
To your point, companies have come to us. We're partnered up. We're going. Collaboration is key to our DNA. It's in our value proposition. It's the type of thing we're asked to memorize. It's that important to our organization. But I also want to say this, right? We've built the architecture for operators. Look, if this is your universe and your data and is proprietary, and you want to build your own models, your own algorithms, all you got to do is plug it in. And you can tell us as little or as much about how you want to control the fleets, you want to use this data as you want.
Really? So you can. It's not necessary. It could be like, here's all your data. Do with it what you want.
Right. Yeah.
But see, the thing that kills me is why would anybody do that when you have the whole system you can optimize it, right? And maybe they think they can optimize better than you guys, but
maybe
if it's all built, in house and it's all interoperable and it was designed like that, that's always going to be your best outcome, right?
Yeah. The operators have their institutional knowledge. They know their asset the best.
Right.
We are the service providers. We are there to provide tools and work with them to maximize the value there. But they do have that institutional knowledge, and as Price was saying, we are trying to provide them access to a platform where they can work safely, where they feel comfortable coming in and looking at all the continuous data that we are acquiring, tie it with their institutional knowledge, and then look at it deeper.
Right.
So we are enabling that.
Right.
Excellent.
Remove the barriers, essentially, to enabling all this to happen. And, our goal is, frankly, you saw sort of the automation of the surface. We want to automate the subsurface.
Yeah. Oh, my goodness. That is the dream, right? That is the dream.
It's not too long, Jeff.
I know. You guys are doing it right here.
Yeah.
So, Faraaz, thanks for being on the show. Price,
thank you.
Pleasure talking with you. I think I'm going to go grab some barbecue, man.
It's good. Yeah. I'll recommend it.
Thank you.
Thanks for tuning into this special series of World Oil Deep Dive, your go-to source for the latest technology in the energy industry. We hope you enjoyed today's episode and gained valuable insights to help drive your business forward. Be sure to subscribe so you never miss an episode, and follow us on our social media channels for more updates and industry news. Feel free to reach out if you have any questions or topics you'd like us to cover. Until next time, keep innovating and stay ahead in the energy sector with the World Oil Deep Dive Podcast.